Today we're going to start talking about what it means to combine like terms. So I need everybody to make sure that they have this piece of paper in front of them. If you do not have this piece of paper in front of you, I want you to go ahead and pause this video and get it, as well as maybe get out a color or two so we can highlight the key facts. So the big thing we're going to do today is what's called combining like terms. So I want to highlight my title so I remember to reference it later if I need it. And the big thing of today is actually understanding what all of this fun stuff means, combining like terms. If I can understand what those three words mean, then I'm going to be able to do this successfully. So in past classes, we've talked about combining like terms. We've talked about order of operations in PEMDAS, GEMDAS. And if I just, you don't have to write this problem down, but if I were to just write a problem like that down, looking at a problem like this, I know I have to follow PEMDAS because I have just numbers. And then we talked about, well, what happens if I replace numbers with variables, and then I say x equals 1 and y equals 2, right? I can then easily take those values and plug x in for x and y in for y, and then I can just follow PEMDAS. But if you take a look at these problems, like some of these problems down here, right? Notice I have variables and I don't know what those variables stand for. So in math, our goal is still always the same. Our goal is still always to clean up a problem. It's always to simplify and make a problem simpler. And so how we do that when I don't know what a specific variable equals is I do what's called combining like terms. So I want to be able to know what these three words mean, okay? So I know combining. In math, when you want to combine something, what does that mean you're doing? Well, that means you're adding. So I know everything I'm doing today, since I'm combining like terms, I know all that I'm doing is adding. So that's actually what our goal is going to be. So I want you to highlight in a color, and let's make sure I click on the right color here. Highlight where it says goal, and that's like the most microscopic highlighter. There we go. My goal is to add like terms to simplify an expression. So again, everything I do in math, my goal is to make it simpler. My goal is to simplify it. So our goal here is we're going to add our like terms together to clean up the problem. So last time we did have mentioned, we talked about what it means to be a variable. To be a variable, remember a variable is just a letter or symbol to represent an unknown number. So let's write that again. A letter or symbol to represent an unknown number. So I can use the letter X, I could use a smiley face, I could use the letter S, I could use any letter or any symbol that I wanted to. Famously, we always like to use the letter X because it's the easiest letter they think to write, even though I know that can be confusing because sometimes that looks like the multiplication symbol, which is why we just don't use that symbol for multiplication anymore. So now we want to talk about what it means to be a term. In order for something to be a term is one of four things. So a term can be a number. So an example of a number would be 5. A term can be a variable. So an example of a variable is x. A term can be a product. And in math, product means what? Product means to multiply. So if I take my number and my variable and I multiply together, 5 times x is just 5x. Or a term can be a quotient. A quotient in math means a division problem. So again, if I take my number and I take my variable and I divide, remember we don't use this symbol anymore. We would then use the fraction bar to be a quotient. Okay? So a term is made up of one of these four things. It can be a number, a variable, a product, or a quotient. So one really important thing we have to remember, and we're going to put it in color, is terms are separated by plus or minus signs. And I'm going to put a cloud around this so my brain remembers. So whenever I'm combining like terms and I'm working with terms, I usually will draw slashes separating them. So what I do is before every plus sign and every minus sign, I'm going to draw a slash. Draw a slash. Oops, if I can draw it appropriately, draw a slash here and draw a slash here. So now it says how many terms do I have. So if I look, I have 1 term, 2 terms, 3 terms. So I have 3 terms. The nice thing about those slashes is it really helps you distinguish how many terms you have, and it helps you distinguish what's positive and what's negative. So notice 7x is positive, 4y is negative, and 5 is positive. 7x is a term, it'd be considered a product. Negative 4y is a term, it would also be considered a product. And 5 is just a number, it would be what's called a constant. So if I look at number 2, I'm going to do the same thing. Before every plus sign and every minus sign, I'm going to draw a slash. And now I'm going to count my terms. 1, 2, 3, 4. So now I have 4 terms. So 9x squared is still a product because it's 9 times x squared. That's a product. Negative 3x is a product because it's negative 3 times x. This fraction, x over 2, is a quotient, x divided by 2. And negative 1 would be considered a number. I want you to pause this video and I want you to try number 3 and number 4. I want you to determine how many terms they have, and then I want you to unpause the video and we'll go over it. So if I draw my slashes, I have 3 terms. This is a product, this is a product, that's a number or a constant. If I look at my last one, draw my slashes because it helps my brain, I have 5 terms. This is a product because it's 1/2 times z. This is a product, this is a number, this is a product of a lot of variables, and that's a number. Okay? So with our main definition here, our main heading, combining like terms, we know combining means to add. We now know what a term is. A term is separated by plus or minus signs. So now I need to determine what a like term is. So I'm going to erase this, but if you need to pause the video, pause it so you can finish getting stuff copied down. So a like term is where things get a little more interesting. So I always use the perfect example of McDonald's. I'm going to blow up here my McDonald's spreadsheet here so we can look at it. And I'm sorry because I might make some of you hungry. So I'm going to go to McDonald's and I'm going to decide what I want to order. Here's what I'm going to order because I'm really hungry today. So I'm going to order all of this stuff. I'm starving and I'm not sharing with anybody. So if this is what I wanted to get at McDonald's and I wanted to order my menu, would I go up to the McDonald's menu person and say, hello, I'd like a medium french fry, a Big Mac, a medium french fry, a small french fry, a Big Mac, a large drink, a medium drink, chicken nuggets? No, I'm going to combine them. And instead, I'm going to say I want 2 french fries, 2 medium french fries, 2 Big Macs, 1 small french fry, a large drink, a medium drink, and 1 order of chicken nuggets. And if I eat all of this by myself, I'm probably going to get sick, but it's going to be worth it. Let's try it again. Here we go. I'm going to order for somebody in the class. Hopefully it's you. And here's what we're going to drink today. We're going to drink some Cokes, Coca-Colas, and we're going to get some of these. Now, if we're feeling hungry, very chicken nuggety here today, how would I order this? I would say I want 4 medium french fries, 3 large Coca-Colas, and 5 orders of chicken nuggets. Okay? Now, we have to be careful about sizing. And we also have to be careful about noticing I'm not ordering what I don't want. Notice I did not pick the medium drink, the small french fry, or the Big Mac. I'm not going to go and tell them I want 0 Big Macs and 0 french fries, small french fries, and 0 medium drinks. I'm physically telling them exactly what I do want. Okay? So if I were to do this is all we're ordering because now we're on a diet because we've just gained 400 pounds. And I go up and I tell the person at McDonald's that I want 3 medium French fries. And when you get your order, if you get 3 small French fries, are you going to be happy with that? I hope you say no, because you shouldn't be happy with that. But no, you're not going to be happy with that because you want what you ordered. You ordered 3 medium French fries, not small French fries. So order really matters, okay? And size really matters. And you don't want to look like a crazy person where if you order all of this food, you don't want to go up to them and go, 1 medium French fry, 1 medium French fry, 1 medium French fry, 1 chicken nugget, 1 chicken nugget, 1 chicken nugget. You want to physically combine them and say, I want 3 medium French fries and 3 6-packs of chicken nuggets. Okay? That's all combining like terms is. So if I pull this and we get started and we talk about what it means to be a like term, let me scroll down real quick. So I'm going to highlight where it says what it means to be a like term. So what are like terms? Like terms can either be numbers, so just numbers, or like terms are variables that are the same letter with the same power. And power is just a fancy word for exponent. Okay? So, if I look at this McDonald's example real quick right here, and I scrolled a little prematurely, but I'll come back to it in a second. If I look at this example, I have 2 hamburgers and 3 hamburgers. I want to get a total of 5 hamburgers. And then I'm going to get a total of how many French fries? 4 French fries. Nope, I lied. How many French fries am I going to have? I have 1 French fry here and 2 French fries here, which make 3 French fries. And then how many drinks? 4 drinks. If I come down and look at this picture, I have 4 drinks here and 5 drinks here, so that's going to make a total of 9 drinks. And I'm going to get a total of 2 hamburgers and 3 hamburgers, which makes 5 hamburgers. And then I'm just going to get 3 French fries. Okay? And notice I'm not combining the drinks with the French fries. If I can't combine chicken nuggets with a hamburger and get a McChicken, that's not going to work out too well. Again, I'm not going to be satisfied with my order. So if I look up at that one I scrolled up past, 5 hamburgers plus 2 French fries plus 3 hamburgers is going to be a total of 8 hamburgers plus 2 French fries. And again, if I'm eating this, I'm probably going to gain 4,000 pounds, but it's okay. It'll be worth it. So notice I'm combining the terms that are alike. Terms that are alike are the terms that have the same variable. So in this case, they have the same picture, okay? And they have the same size. So just like before, we can't add a small French fry and a medium French fry and get a jumbo French fry. So if I look at this following examples, it says, can the following be combined? Can x and 2x be combined? Yes, because x and 2x both have the same variable x, and they both are the same size. Their exponent is the same. If I look at number 2, smiley face and frowny face, can I combine those? No, because one's a smiley face and one's a happy face. One's a smiley face and one's a frowny face. If I look at number 3, 7x squared and 3y squared, notice the squareds are the same, but are the variables the same? No. So the variables are not the same, so no, I can't add them together. That'd be like saying x would be drinks and y would be French fries. I can't add a Coca-Cola and a medium French fry and get something else. That just doesn't happen. And if we look at 3a squared and negative 7a squared, can I combine that one? Yep, because they have the same letter, a, and those a's have the same exponent of 2. Okay? So the big question of the day is, how do I combine them? Well, we already talked about combining mean what operation in math? Combining means add. So all I'm doing is adding the coefficients of like terms. Okay? So I like drawing my slashes because it helps me. You don't have to draw the slashes if you don't want to, but it does just help me. So I'm going to draw the slashes. So I'm going to draw the slashes before every plus sign and every minus sign in the problem. So I always work from left to right. Looking at 4x, what is a like term with 4x in that problem? Well, the like term is 9x. So 4x and 9x are like terms because their variables are the same and they have the same exponent. So all I'm doing is adding the coefficients. So what's 4 plus 9? 13. And then I'm just putting an x next to it. Because if you don't include that x, I don't know what you're talking about. It's like going up to McDonald's and being like to the McDonald's cashier and being like, hello, can I have 13, please? They're going to look at you like you're a little crazy. So you want to make sure you want 13 French fries. Okay? I can cross these out because I've used them. Look at 6. Can I add 6 with anybody in this problem? No, so I just add it to the end. Okay? I know I'm done because 13x and 6 can't be combined because they're not like terms. 13 has an x and 6 does not. So now I'm going to go down to number 2. I'm going to draw my slashes, and I always just work left to right. 3x squared, who can I combine that with? I can combine that with negative 2x squared because they both have the same letter and the same exponent. So 3x squared and negative 2x squared. So 3 and negative 2 make 1, so I can just do 1x squared. And then I'm going to cross those out. 4x, who can I combine 4x with? Negative 2x. 4 and negative 2 make 2x. And I'm going to cross that out because I used it. Now 8. Can I add 8 with anybody? Nope. So he gets slapped on at the end. I know I'm done because none of my terms are alike. I can't add x squared with x because they're not the same size. It's like saying small and medium. And I can't add 8 with anything else because there's no other one that has a variable. Order doesn't matter for right now. If you had rearranged that in a different pattern, that would have been fine. However, I just always work left to right. If I draw my slashes on number 3, 2m I can combine with negative 4m, and I get negative 2m, and I'm going to cross them out. And then 3m squared, can I add that with anybody? Nope. So I know I'm done because negative 2m and 3m squared can't be added together because their variables are the same, but their exponents are not. I want you to do 4, 5, and 6 on your own, and then I want you to come and get your answers checked by the teacher.